Hello, folks, and welcome to another episode of Into the Terminal. I'm your host, Nate, today, and of course, I'm not joined by Scott. This guy does not look like Scott.
No.
This is Matt. Matt is another member of our TMM team. You may have seen him on some of our RHEL 10 beta streams, but we're here. We're talking about image mode and working it into CI/CD pipelines. And while I have some experience doing that, Matt is the guy that I went to for help. So we figure if we're going to talk about it, we might as well have Matt on. Plus, Scott is on a mountain somewhere with the Boy Scouts.
Yeah, right. One blog post, and now people think you're an expert. So
it's funny how that works, but
yes,
that really is how it works.
I do have, and we can talk about this later because we do have actually a very interested team of folks that I have pulled together as a result of this, who are actually experts in things like CI/CD pipelines, and we've got some more resources than the blog post I wrote and the actions that I helped get started. So
cool. All right. Well, you have a little bit of a demo for us to get started with, so let's move right on into there.
Sure.
I am also not a CI/CD expert, which is another reason I brought you along.
Yeah. So, last week you were talking about sort of the sort of local way that you were, that we usually start with image mode, and talking about needing to do updates and things along those lines. So one of the things I figured I would do, since this is a real world application, is so we have this, right? This is our bootc base image. This is the source we're pulling from the Red Hat terms-based registry. And you notice there's a weird tag here on the end. We're not using just straight 9.6. We publish these with basically, that's just a Unix epic timestamp. So like it's the build date. And one of the things you can then do is you're making sure that exactly, you're not just pulling whatever random latest 9.6 happened to get published that week. That you need a little more reproducibility in your images.
Right.
But we publish these things, right? So if you look in the container catalog at that particular tag, you will notice this admonition that we strongly recommend an update because we published a new one. So let's go ahead and do that with the very, very advanced copy paste techniques.
I mean, it's that, or you have to remember that big long number and type it in exactly. So I'm not going to slight you for copy paste.
Yes. Or, you could just guess random timestamps and hope we built something like that.
There you go. That's a way to do it.
So this is very much the same sort of thing that you saw yesterday, right? Yesterday, I guess it was last week, right? It's Vim. It's NVim because I'm feeling fancy.
Fancy.
But the other thing you might notice if you're sharp-eyed or if you've seen this before is this little main thing here, right? This is a signal within NVim that this is, in fact, and also in my prompt, this is a Git repository, right? So if you're not using Git today for all things, you should probably be using it. We can talk about that later. But part of Git ops, right, is using some sort of Git-based system to update to latest Red Hat base. Let me finish typing so I can talk. Is that you can make these sorts of changes and you can record them, and then also doing the things that you were doing, right? This is just really basic, right? We've just got a bare Git repo. We made a change, and now we would go to build it to get the update to actually use it, right? Instead, though, I want the robots to do it. So GH, that's the GitHub CLI tool, right? So like Git, there is a GitHub CLI that lets you do various different things. And this workflow, this lives in the Git repository. It defines a set of what they call actions that uses GitHub's built-in tools to run jobs, to do all sorts of things that you need to do in order to run some sort of continuous integration system, right? Compile code, do whatever. We are using it. And the thing that I figured out how to do was how do we run this? And we can go ahead and just show that it's, oops, I have to copy before I paste. right? I have a whole bunch of them. Some of them have failed. Some of them are working.
Yeah.
And we can actually see what is going on with this particular job, right? And it is running out and it is going off and doing things, and I can get more logs here on what it's doing, right? So what this is all just terminal stuff that leads into, right? This is just using the API to drive the same thing you would
Right.
web UI, right?
So to clarify for people that are trying to follow along here, what Matt did here is he updated his container file, and then instead of building that container locally, he pushed it into his Git repository.
Correct.
And by pushing it into the repository, he's then able to fire off a GitHub action to build the container, right? Which is, if you're building containers, if part of your daily life is building containers, this is probably not news to you that this is how people build containers, right? You've got a Git repository that contains your code and how the container is supposed to be built. And, you're not manually building these containers when you need them built out. You have automation that does it for you. And that's exactly what Matt's showing us here.
Right. And it's similar to what we do, right, in the infrastructure world too, right? Like we don't manually, well, hopefully most of us, because I still do it on occasion too. We're not grabbing the RHEL installer, firing up a virtual machine,
right,
manually typing a bunch of commands and then exporting that somewhere in order to do our builds, right? Like we have Ansible, Terraform, Puppet, whatever involved, and hopefully all of those things are also somewhat stored in Git so that you can work together as a team, right? Because the thing that I didn't do here, which I probably should have, but this is a literal private repository, right, is you get the ability then to do things like create a pull request, which allows you to ask somebody else to review the changes, right? So you can say, oh, this is what we want to do to our production environments. Nate, would you look this over and make sure I didn't screw something up? Works on my machine, but like let's review it like it's code and we're working on a team together.
Right. Right.
Let's go ahead and jump over to the actual repo here. Let me pull up. That's an old one, so we can actually see, right? This is now the web UI. I'm logged into my account on GitHub, and we can see like this is just a proof of life. Like this is actually running remotely on GitHub, and right, it's talking a little bit about what it does. Like these are individual actions. These are just basically little scriptlets, right? The language isn't particularly hard to learn. I had no idea what I was doing when I started this, and managed to get it working in about 2 weeks. So it's pretty simple. And
there you can see the container build happening.
Right, and this is what sort of. This is the interesting parts, right? This is actually containers in containers. So this step of builda is actually running inside. You can see it here where it says bin docker exec. All of this is running on GitHub's free stuff. Like I don't have hidden machines running any of this. This is all running on the infrastructure they provide for free accounts. You can do self-hosted and all sorts of other things. So this is all working completely on somebody else's machine. It's actually using real subscriptions. These are parts of the things I had to work out. Was like, how do I get subscriptions into a Docker container? That
was an interesting hurdle when I built mine. I built something similar on GitLab, which we're going to show in a little bit, and maybe I'll walk through a little more of how I made that work when we get there.
Right. Yeah. So this is, we're letting robots do the work of building a new image, right?
Yeah. And we'll touch more on why that's important and what that really means for us operations folks that maybe weren't doing CI/CD pipelines or weren't considering doing CI/CD pipelines for our RHEL server builds, right? Because that's the state that I was in when I was still in the industry. We had build automation, but it wasn't like this. It was not. We did like Kickstart with Puppet that came in afterward, or Ansible, whatever it is that you wanted to replace your automation of choice with. But this is a different level. This is a different type of build automation.
Yes. It looks like we've got some minor local failures with something going on here.
You broke stuff.
stuff, which is always the good thing when you're
Yeah, well, I mean,
doing
just wait
things
till you see the logs of my my jobs. It's like fail, 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 succeed.
live. But this seems like it's working, so I don't know why it's tried 3 times. So maybe there's probably just something. Yeah, okay.
Yeah.
So this is
Okay.
probably something. Oh no, there we are. So we're in the commit, and it is moved on. In
Right.
fact, it looks like it's actually completed. Cool. So yeah, so that literally now I have an image published just like you did last time, except I didn't do any of the like manual typing of build commands. I wrote it
Right.
once,
Right.
and now I can just make changes and have it trigger and do work for me.
All right. So, folks, we're going to get a little bit deeper on these topics in just a second. But remember, if you're liking this content, make sure you let us know by hitting the like button and subscribe if you want to watch this stuff. We do this weekly, and not this specifically. We do this show weekly about lots of various different topics. Some of them are more sysadmin centric. Today, we're a little more, I guess you could call it developer / sysadmin, DevOps centric, right? We got a DevOps episode, which is a first, I think, for Into the Terminal.
I'm happy to be the first. I've been a huge proponent of DevOps since I was a younger. I won't say young because it's only a decade ago. There was less gray in the beard, but
Yeah.
it's not that long ago. Yeah, this all harks back to things that I was trying to, when we first got some of the DevOps stuff going on, like I got jealous of like, hey, look at all this stuff they can do. Why can't we do that? And now we can, which is kind of cool.
All right. So we'll be back in just a second, and then we're going to dive a little bit deeper into what all this means. And that's it. We're back. I couldn't even get a drink of his water in.
Almost got it.
Almost. All right. So, what we just showed there is using automation, not just automation, but using container automation, because that's essentially how you would build a normal container, right? If you were building anything, some container application, containerized application. That's one of the common ways in which these things get built. And I've been doing that for, a handful of little projects. And I know there's folks out there that probably maintain hundreds, thousands, perhaps even, of different container images. And the thing that makes this novel is that we're doing it for a full installation of RHEL here, right? With RHEL image mode. So, Granite Penguin says it's not a demo without a fail. Probably when you were talking about the errors you got there.
Probably.
So yeah, that's probably true. Probably true. I don't know if we'll have any more failures today, but maybe we will. Now, obviously, that build took some time, so we couldn't really watch it get completely to the end. I guess it was almost done there, wasn't it?
It actually is done. That build a step with its failures is the longest step at about 5 minutes. So we actually managed to talk through the entire thing here. Like we can scroll down and I can show you the rest, but we got the little green check mark.
Are you saying we talked too much? Well, here I'll switch over to the
probably me, right? Like I'm going to close. I was trying to close these before we clipped over, but like there's a little green check mark and there's the time on that, right? Like that's 5 minutes. Everything else is in second.
So it did finish the build that quickly. My GitLab instance does not get it done that quickly, but there's lots of factors there.
Other people's infrastructure, right? Is
right.
We're not running it on like that. And this is maybe a little too inside baseball, but during the beta, Nate and I were doing a RHEL install on a NUC, and that is currently dead because I have attempted to rebuild said NUC with RHEL on it using RHEL 10 in image mode and haven't gotten around to finishing it. But yeah, that is not a fast build either because that's an old system.
Yeah. All right. So I guess what we wanted to dig into a little bit here is, how did we get here? How did we get from the world of package managed RHEL, package mode RHEL, to where we are today? Because there's sort of a history here, right? I mean, we went from the world where everybody was installing operating systems from physical media, and then of course, like USB sticks and whatever. I can remember that. That was the beginning of my career. That's how it was done. And then we had like Ghost. Remember that when you used to image
Mhm.
machines from Ghost or something? And then the whole space just sort of took off, and we just started like year after year. There were these incremental improvements in how we can deploy operating systems, not just Linux, although that's what we're talking about today, but in general. Like, how do I pixie boot a system? And then Kickstart, that's really cool. Let's automate that. Let's build virtual machine images to use as templates, right? So yeah, I guess I'm rambling a bit there. So there were specifically some technologies that led into where we are now with image mode. And I think you have a little more insight into those than I do.
Yeah. Part of it is that I was actually in some of the communities early, again, 10, 15 years ago when some of these first concepts came out, right? And it kind of ties into, people get confused because we're doing this with containers. Suddenly this is somehow, you know, containerized RHEL that is being run somehow. And it's really the OS, the image management, like that portion of what goes on the live host once it's installed, right? Because again, these are all for installing onto a virtual machine, onto a cloud, onto bare metal. Yes, bare metal. You can kickstart these things. So a lot of that comes out of, if you think back, and some of it's not even that far back, the atomic desktops in Fedora, right? That's where a lot of these things come from. We have CoreOS that sort of was very focused on being a container host, right? Like Kinvolk and Flatcar and Project Atomic, all these things we did, like they were all very much in the early days of, oh, we need containers and we need Kubernetes, and we have these specialized hosts to build them. And that's where the first sort of, it would be really cool if we didn't have to have fully managed standard RHEL, standard operating system images. Like
And
if we could get some of that
those were
image based.
those were very purpose built. They were almost
Correct.
designed to be a worker in a Kubernetes or an OpenShift cluster.
Exactly.
Right.
Exactly.
They weren't general purpose RHEL.
Right. Right. And in fact, I remember I was in Brno at DevConf CZ, and one of the I don't remember which of the maintainers of Project Atomic it was. Like this is probably 2016, 2017, maybe. Showed up with a desktop that he had been running with OS tree, which was what we're running the container host node for Project Atomic on. And I was like, wait, what? You're running a desktop based on this stuff? And that was the start basically of Silverblue and all those things.
Cool.
But even then, right, that is still like there's a lot of Flatpak and it's very purpose built for desktops.
Yeah, Silverblue, I found, I never switched to it. I thought it was neat, cool idea, but it never felt usable enough for me for the stuff I did on a desktop.
Right. So the bootc stuff, right, that is actually sort of logical successors to RPM OS tree and things that came out of CoreOS, things that came out of Project Atomic that show up in other parts of our portfolio and in Silverblue and other things. The container stuff that we're talking about and why we can do these, like put things on GitHub, put things in GitForge, that is an improvement to how the images themselves were assembled and delivered, right? OS tree has a very new, like it built its own image format, and therefore it built its own way to actually build the things and then ship them via HTTPS, right? You just put them on a web server, and then like you had to have specialized tools to do all that, which made it difficult and had other challenges. This takes all of that assembly process, uses the container file definition, the tooling that was already built to build fancy tarballs, right? Because that's all container is, right? It's a tarball set of tarballs with some metadata, and they already have a distribution mechanism that tells you all sorts of things about what's inside of it.
Right.
So really the container part of this, and why I don't use, like we talk about bootc images and bootc in particular, and not a lot about what upstream calls bootable containers. And even this is from Colin, the lead developer, is like, bootable containers don't boot. bootc unpacks them and turns them into a bootable thing.
Yeah, it's basically a transport for a disk image.
Exactly. And
so the container itself, while it can start in a container runtime, which maybe we'll show in a little bit, It doesn't boot exactly. It runs like a container if you run it inside of a container management system, or if you run it
Yeah,
underneath a runtime like Podman or Docker. Actually, can you run them on Docker? I guess you could. The bootc.
yeah,
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 okay.
because these are
I didn't
all
want to
OCI
misspeak there.
standards. No, and
Yeah,
that's kind of the drive, right? Is that the container file itself, the image that gets produced, the ways it gets sorted, like these are all OCI standard things, which allows us then to say, oh, well, okay, you have GitHub Actions, cool. Can you run OCI stuff? Yes. Oh, you're using GitLab, cool.
yeah,
What if somebody in the audience is using Jenkins? No problem. Um, Using OpenShift and want to use a Tecton pipeline, cool deal. Ansible knows how to start and stop Podman things and
right.
run Podman commands. Cool, no problem. In fact, the very first version, my very first attempt to even prove this, I just used the off-the-shelf Docker X build actions out of GitHub, and those worked fine. It was complicated and I couldn't understand what was going on. So I started over. But like the very first, like, can
It
I
works,
do
but I
this?
don't know why.
Yeah, exactly. Pretty much. But I bring it up simply because one, I like to enjoy, I like sharing failures. But two, like it's OCI standard stuff. So I just grabbed something off the shelf, said, here's a container file, here's a registry. I was using this to send off stream stuff, so I didn't have to worry about like credentials, but I was like, here's the registries. Can you build it? And I was like, yep, here you go. It's like, oh, this actually works. Like this promise. This isn't just a promise of use any of these tool chains. It really means you now have access to any tool that knows how to do containers to build RHEL and drive your automation, right?
Right. So we did have a quick question, which is not exactly related to the thread, but I don't want to lose it. And then we can move on to kind of why we think this is important. And the question is, how do you handle one-off package installations and removals without having to restart the system to apply the changes? Now, I think that can be read two different ways. One would be, I just need this package installed and it's going to stay there. Or the other is I need to install a package for maybe troubleshooting purposes or to do a thing I'm doing right now, and I will remove it when I'm done. So I don't know if there's different ways to address the two different use cases.
Not really. So it's sort of the same mechanism, and it's brand new. So we just got this fixed in RHEL 9, 6, and 10. And again, this is sort of, these are things that there are folks who are familiar with the way that OS tree works out of the niche areas that use it today. So there's some parity things that we're working on, but essentially we taught DNF. We said, hey, DNF, like we need to be able to install packages on a host that you can't write to user. Good luck. So they've got this idea of transient installation, right? So you can do things on an image mode system because it's got overlays and all sorts of other fancy, complicated file system stuff available to you. That let's take your second example first, because that's the one I think a lot of folks are going to find themselves in. Let's say you need to install an agent to troubleshoot something that is not something you would normally carry in the image, but
I need to put on Netcat, or I need to run a TCP dump.
My database vendor needs this to actually be installed on the system in order to troubleshoot a thing, but I don't want to have it there all the time. So you can just DNF install. There's a new flag called -- transient. It essentially builds a new overlay that is writable, and it survives for as long as the host is up, right? So you don't really need to worry about uninstalling it, because the next time you update the system and reboot it, that layer gets discarded and it goes away. If you do want something permanent downstream, that's probably where you want to look at, okay, if we really absolutely have to have this all the time, then we probably need to think about adding it somewhere in the build process.
Right. So you could install it to do the thing you need to get done. But if you're like, boy, this thing really needs to be here after a reboot, that's when you need to think about, this has to be built into the image that I'm running on this machine.
Exactly. Yeah, and that's a decent use case too, right? Is, if you find that you're installing something over and over again,
really, this is a similar paradigm to blessed or golden images for your machines, right? Ideally, you want the entire package set that you care about in the image. You don't want to have to come back in and change stuff afterward. You can certainly do that with automation. There's lots of ways to get that done. But one methodology there is, no, we don't install stuff on our machines. We put them in the image. And this is more or less just kind of a little more forceful at that exact same methodology.
Yeah, exactly. Yeah. And you can do the same sort of like separation of, well, these are for applications and these are for like the system stuff, right? So you can have your standard base that has all your admin tools, and then, okay, but the database systems need this and the web app systems need these. Okay, so we have new container definitions that just the image, we inherit the first one that we built, which is our sort of admin standard base. And then we add whatever for app servers and then whatever else for database servers. And now we have two different sets of downstream derived images that you can start modifying the same way that you would for, you know, controlling automation to say, okay, we build this and then we fire off the playbook that does database installs just on database hosts.
Right. Okay, so one other point we wanted to kind of touch on. I think we touched on everything else we have in our notes, and that is what's the attraction? Like, why would I want to change from what I'm used to an image mode world? And we had one example in here about sort of like a cascading update, right? So like a container, right? You base image mode on something, right? So there's always that from line at the top. Whether that's an image you built or whether it's an image you're pulling from an upstream, there's always that base, right? And in my mind, a great way to use that in an enterprise or something is you guys, you build yourself your base image, which has all the basic stuff that you care about, all the checklist items that you have to have, all of the compliance. We didn't really touch on that, but you can do like OpenSCAP compliance right inside of that container file now. And that's your base. That's your blessed. Your InfoSec team has said that is the OS we need to run on everything. But then, of course, you have these other use cases. We just talked about package installations. I can't just roll that out to everything and then install my stuff with whatever after the fact, because the first time I reboot it, it's all going to go away. So what you would do is you'd then base other variations of that image on that image, right? But the really cool thing about that is, say there's some crazy vulnerability comes down the line, there's another Heartbleed or another shell shock or something, and you need to patch that everywhere. You patch it in that base image, right? And I have an example. Maybe we'll show it next. I don't know. We have an example where I've done this exactly. I've made a base image and then I've made a sort of sub image, right? You patch it in that base image, and then all you have to do is, once that is built and passes your tests, which of course you can test all you want on that container, and then you can test it on a deployment somewhere, physical or virtual or whatever, make sure it does the stuff that it's supposed to do. Then you just trigger rebuilds on all of your downstream images. Maybe you have to change the tag that it's tracking. Maybe you have to change it. In my case, I'm just tracking latest. But if you're doing what Matt was showing earlier, where you were tracking a specific release, you'd have to update those in all your container files. You rebuild those, and all of a sudden they all have the update, right? And then all you have to do is schedule maintenance windows for all the machines that are using that image to pull down the latest image and do a reboot, right? And we talked last week about how that's really easy to roll back if necessary, right? Which I think is another really key feature of image mode. Did you have like comments on that, Matt?
Yeah, I think the one thing I want to like stress, right, is everything that you just talked about is all offline work, right? Like there's nothing that touches the system. Like when you've got something, like when you think about it again, we'll go back to a Heartbleed, right? Like remediating it is like, cool. Ansible told, or Insights told me about it and I have a playbook, but like now I have to go touch live systems everywhere.
Now I've got to run it everywhere.
Right? The test is, okay, let's go to development environments and hope it doesn't break our app. Right. But you got to kind of do it all the time. You got to do it live.
Yeah. Not to mention, how many times have you gone to update a package on a production system and you find out there's some weird dependency failure? There's a DNF problem. The RPM database got corrupt and you had to nuke it. something, right?
Or the
That
network
prevents you
pickups.
from getting that thing done at 2 a.m. when your production database needed to be updated.
Yeah. So the other thing that lets us do, and I also have a demo, well, it's more of I can show and tell. The demo's a little, maybe not interesting.
We found demos tricky for this episode because of the
Yeah.
time it takes to rebuild these images.
Yes. Yes. So like we can trigger some stuff and then go like, okay, and this is going to work in the background. But some of these things that we're talking about, right? Like we also benefit from the fact that other people have been working on these problems for 10 years, because the idea of, okay, well, I just updated a container file and I have all these dependent images. Like, what do I do? Do I do that manually? It's like, no, other people already solved this problem. And you can do something like there's a bot called Renovate that will automatically monitor all of your dependencies and push a pull request to your GitHub repo saying, Red Hat updated this image. You might want to, and like it gives you the pull request to just merge. So while we introduce new problems, we're introducing problems that are sort of solved because we're using these technologies that are actually pretty mature. So I don't know, we get access to a whole lot of things that we really didn't have before. That we can sort of use to make a lot of the things we would normally do anyway, right? Because you got to keep up with syncing things out of satellite and making sure you're updating your lifecycle environments and doing all that, and making sure those schedules are working. Like you don't lose a lot of that when you move to automating things through the container paradigm of an image mode host.
So we've talked a whole bunch and we haven't done a lot of screen sharing. So let's see. I can go through my GitLab stuff, and then you had another demo, or at least something to talk about regarding tagging. So maybe we'll do that one after.
Yeah.
What do you think? Okay.
Yeah, it works.
So let me switch screen shares here. You're going to see Matt's again for a second until I switch it. There we go. So now you're looking at this is my personal GitLab. I run this. This is a GitLab community edition system that I'm running. So again, right, I didn't have to pay any extra for the features that I'm going to show you here or anything like that. But this is a repository that I made specifically to build a RHEL 9 image mode system, which is why it's called RHEL 9 image mode, as you might guess. The only reason I haven't started with 10, which is what I was going to do, is there's a dependency I don't have yet on 10 for something that I wanted to do. So that's the only reason I'm doing. I should be able to just change the image I'm building from to switch this over to 10 later, which is what I might do. So what I wanted to show you was the CI integration that's built into GitLab. And this is, remember those steps that Matt was showing earlier? These are essentially how those steps get defined, at least within GitLab. I don't know what they look like in GitHub, but you see there's like this definition sort of declarative language here where we're telling it like this is the script to run before we start the jobs, right? This is what image this should be based on. Now you might notice that I'm using a local Podman builder. I'm building 100% on Podman. The GitLab instance runs on Podman. They call it Docker in Docker, but it's actually Podman in Podman that I'm using here. And this is just based on RHEL UBI, right? So the build environment that I'm using is based on RHEL UBI instead of a full RHEL installation, which is going to be important in a second. I defined some stuff in here, which is really not all that interesting. But then we run this before script. It installs some tools that are going to be needed to install, to actually build the container out. And then it does a subscription manager command. And you might be like, why in my build environment would I be running subscription manager to register this UBI container? Because at this point, when it's running the before script, it hasn't entered the container environment. It's got nothing to do with RHEL yet. It's just setting up the environment. And this is because when you build a RHEL image mode, or I should say a RHEL-based container in general, what it does is it uses the host that you're on to inherit the entitlement that says, yes, I'm allowed to build RHEL. And we had to do that simply because of the way entitlements work on RHEL, right? So that's just kind of the way it has to be when you're building RHEL. So this is registering this host, and then all the way at the end, one of the last things I do is I unregister it so I don't end up eating up a bunch of entitlements on these build containers that are just transient, that are going away, right? Let's see what else. We got some variables that we set, and then I log into my container registry, right? Or sorry, I log into this is the Red Hat container registry, so I can go and get the image mode image, right? There is a point where I log into my registry, but I didn't cover that. Oh, here it is right above it. So, and this is because in order to push to a registry, generally, unless it's a public registry, you need to be logged into it, right? So these are things that I'm just setting the stage for building the thing. And then we move into this job that's called containerize. And you can see all it runs is a Podman build command. Now, this might look complicated, but these are just standard Podman build flags that we can pass in to Podman. You can see I'm passing in some secrets, and that's essentially so that I can pass my Podman authentication off to the build environment, right? So once you're inside of Podman doing the build, it also needs to be authenticated it needs the same Podman authentication that I had to begin with. Otherwise, it can't talk to the registries that it has to talk to, and that's why that's in there. Plus, I have some code within the container file which will take that authentication and save it in the image that it builds, so that in the machines that result from deploying this image, I'll already be authenticated to the registries that are required to go and get the image mode images, the bootc images, so that when I do an update or something, I don't have to re-log in, right? That's important stuff. And then the container file itself, oh, I went up too far here. Hold on, let me get back to my registry or repository. Here we go. You can see there's a couple supporting files here, but the container file is where most of the magic happens. You can see that I'm basing this one on the upstream RHEL 9 bootc latest, unlike Matt, who's following a certain tag. I'm just grabbing it from latest because I want this to get the latest one every time I build it, because I'm not automatically rebuilding these things. I'm triggering builds on this when I want it to rebuild. And the only real reason I want it to rebuild is to get updates at this point. I add in the Apple repo. I have a flag. I have a command here that is actually pulling in DNF updates. I don't know if I really need to do that. I could just wait until Red Hat publishes a new version, right? I see Matt shaking his head for some reason. Is this bad?
Yeah, that is generally frowned upon.
Okay.
So the reason why is so you're pulling latest. What could happen, even if you're pulling latest, is you could wind up where you're pulling things that are sort of ahead of where it is depending on what subscription you're using.
Okay.
But typically, we suggest you don't do that. Right. This is where, in order to make it all depends on how much control you really want over knowing what's in the image on disk, right? So depending, because we get back to the reason that we invented satellite in the first place, depending on when builds happen, that means you could have systems that drift because of the build environment, not right in the same way that if you were doing live updates on a host and something happened. In the fire.
This is actually a valid point then, right? Because I did that because I wasn't sure how often we were churning out new images, right? And I thought, well, if the image gets too old, I'm going to want to pull in updates. But if we're doing those frequently, then I probably don't need to, especially if I'm tracking latest.
So yeah, I don't know off the top of my head what our current schedule is, but it is pretty frequent. For new rebuilds. But the other thing is, like, let's say that there's an update to the repos after an image build. That means you're going to actually wind up rebuilding everything that's in the image, because you're going to do a full DNF update, right? So you're actually going to drift away from what the base image was. Like, you might get a new kernel.
Okay.
Right. So yeah, the but again,
So I could
it's
break things
all
by doing this, is what you're saying.
you probably. I mean, it's all within a minor release, right? So this is the thing
Yeah.
about which we haven't talked about, which we can go back to the registry. Like we publish basically 3 sets of tags for like we have the minor release latest, which is literally like whatever is 9.6. So you're only getting like 9.6 updates like you would on any other RHEL repo. It's just right. It's the 200 odd packages that we bundle together and publish as the bootc image.
Right.
So it probably will never really break anything.
But it's
just
still
that
not considered best practice, which is
yeah,
why it's
because it's a
important
little
to mention
harder
it
to
now.
understand what's actually in the image.
Okay.
You said, oh, I
Cool.
started from here, but then I've completely redone everything that's in there. So now it's based off of some point in time that you don't really have any visibility back to what was going on in the Red Hat repos. Now, if you're doing this from satellite and you're controlling that with like a lifecycle environment and you have a snapshotted version and you know what those RPMs are, then the conversation is totally different, right? It's all about what sources you're using and how much you care about being able to identify the contents of the package or the contents of the image from wherever you're trying to do so.
So if this were a signed image or something, I've now muddied it by doing the updates. Okay.
Potentially.
All right. So there's actually a question regarding Podman versus Builda when it comes to you used Builda commands in your build. I used Podman commands in my build.
Yeah.
Mine, I don't know that I had a specific reason to use Podman versus Builda. It's just what I was used to. Doesn't Podman call Builda when it builds anyway?
Yeah, it does. So
Yeah.
there may have been differences in the past, but these days the Podman build is essentially a wrapper around the same set of libraries that Builda uses.
Right.
So it's mostly Builda will give you the ability to do things like do things from scratch in different ways. So the difference between what the action I used, which was it uses a build a bud, which is build from Docker file, is essentially identical to a Podman build. They're just different commands. It just so happens that the action I used was the build a bud, even though I think it may even be, no, I think it's called the build action. But I'm not doing any of the fancy like things I used to do, like build from scratch. And, that's how you make a 4 gig Go image or 4 meg Go image with Builda is like from scratch and like here's a single file and drop it and turn that into a container. Like we're not doing anything fancy.
Right. Right. All right. So that was a fun little rabbit hole there.
Yes. And yes, I am talking about package drift. That was a comment in the
yeah.
Right. If we're trying to control for drift, like this could be a place where we might accidentally introduce drift if we're not controlling all the variables around it.
And these packages here that I've got highlighted are, I should say specifically this one, this IPA HCC client. This is a new feature that came with RHEL 10 and 9.6 that allows you to do IDM realm auto joins through insights, right? So what my experiment here was, I wanted to see if I could build an image mode image that leveraged that feature along with insights, because you then have to register with insights, that I could churn out an automatic build that would come out the other end on my home lab infrastructure, already joined to my lab's IDM domain, already ready to go, right? And that's actually why I need EPEL up here, because those packages are currently in EPEL. I don't think they're in the core Red Hat repositories yet. At least I couldn't find them. I think it's just the features that new at this point. So anyway, that's what I'm doing with these installations here. I'm also adding in Cloud Init so that after the fact, if I wanted to, I could do some Cloud Init actions on the first boot of this machine. And then I'm doing a DNF clean all, which is important because there's data in DNF there during this build that would then remain in the image afterward. And that's not only data you don't necessarily need to include in the image, it's also data that could cause you conflicts later, which I did run into. And there's actually some extended stuff we have to do cleanup, and that's at the bottom of this particular file. Sorry, I'm just looking at the chat. Shantanu says, I'm surprised that no one has invented a requirements.txt equivalent for RPM. I guess that's true. But do you really need one? You just do a DNF install with the list of packages you care about, right? Anyway. All right, so the next thing I do here is this is a first boot service that we're setting up that'll do the connection to Insights, and it includes some organization and activation key details inside of one of the files in my repository. That's what's going on here with this RHC Connect credentials. And then there's a system service that has to be enabled that actually does that on the first boot. And then I like to have suspenders when I build things. So I added a break glass user into this container build. And that's mainly because when I was first building it, I'm depending 100% on that auto join to work, which again, like I said, is a tech preview feature. If for some reason the build does not auto join, I shouldn't say the build, but when I first boot up that VM, it does not auto join, I will have no users to be able to connect to that system with. Now I could come back with Cloud Init and do that, and I may do that. I may take this out of the container file and put that inside of Cloud Init, but for now it's in here. You don't have to do this, but I did it because when I was troubleshooting, I had a couple issues where it came up and I'm like, oh good, why did this particular thing not work? Oh, I have no way to get into it to find out.
Yeah.
So anyway, that's just me.
Yeah. The other thing that aside from like emergency users like that, the other thing that could be interesting. So let's say you are hooking this up to some other sort of like you're going to hook it up to Ansible or something else for managing local state later. You could put a standard like Bootstrap user with a Bootstrap key in all of your images, so that your first automation job would be to log in with known credentials and then replace them, right? So that way you can connect on boot to like Puppet or Ansible.
My goal for this was to not include any authentication credentials within the image. I, of course, went back on that when I was doing this troubleshooting, but that was the whole point of getting it to auto join the IDM domain. In my brain, what I would do then is I would have an automation user that's in the IDM domain that I have more control over, instead of having one built into the machines, because this turns into technical debt. This is a thing that I would then have to manage later, right? I'd have to either come back and remove this later, or I'd have to come back and change this thing's password every so often, and that becomes a pain in the butt. And that's exactly the thing I was trying to solve with IDM. Okay, and then the next thing here is I talked about that authentication for Podman. This is the magic that makes that come on in there. And we have examples of this in a repository that's published by Red Hatters that have done a bunch of other CI/CD stuff. And we have a link for that in our notes. We'll have to make sure that we throw that in the description of the video today. I think, it's this one here in the notes. I'll throw it into chat here. Just give me a second.
Yeah, that's the group of people that I mentioned earlier. Nate finds that link. We've got Ansible things. We've got Tecton. We've got Jenkins.
Right. So
a whole bunch of stuff. The folks are working.
These are folks who've gone deeper into the CI/CD stuff than Matt and I have, and they've published examples of how to make this stuff work. A lot of the work I did here, a lot of what you see in this container file and in that CI file that I showed earlier, was basically copied from there, or at least copied and modified, right? Okay, let's see. What else did I want to do? Oh, there was some stuff here for the timer that auto updates bootc. I have it turned on. You can choose to turn it off. Maybe you don't want to do automatic updates. I wanted to see how it would work if I turned it on. That's why I have this here. And then there's this last line here, which this is important. I talked earlier about that DNF cache. What this does is this tells, or this removes a bunch of that cache data that is not removed with the DNF clean all. And the reason I added that is because I started to build a downstream image from this one, which is actually over here in this repository. And all I'm doing in this one is I base it on that same RHEL 9 image mode. And then as an example, I'm telling it to install virtualization host. In my brain, what I want to do is later, I want to try to build a hypervisor that's based on image mode. And this is the start for that, right? So all I'm doing is installing virtualization host, the group, and I'm enabling libvirt, right? And it was failing on this DNF install because there was cruft left over in the base image. And that extra command that I threw in there at the end did the trick. This deletes var cache var lib DNF, and it removes var lib RHSM, and it removes var cache LD config, right? And that cleans things up to the point where things worked again, right? I was able to build my downstream image. But this actually brings us to the point I was initially trying to make, which is that now that I have this base image, right? I have this RHEL 9 image mode image. I can build variations of that image like this hypervisor image with a much simpler container file. All I'm doing is saying, take the work I already did in that one, bring that in and do these extra tasks, right? So now I could do extra things in here, like, I don't know, set up libvirt networks, or I don't know, something that I wanted to do automatically as this thing was being built out. And then I could theoretically deploy a dozen hypervisors that are all based on the same config, which I think is pretty powerful. And then the updates and management for these things become update the images, bootc update, reboot the machines, and up you come, right? So there's a lot of potential here. The last thing I wanted to show you in these is what the job output looks like when I run it. Now, for these, in fact, let's see, how easy would it be for me to do that? Here, let me switch you over to, let me find the right window. I have two VS Code windows open for these two repositories I was just working with, and I wanted to modify one of them and show you what happens. So let me switch screen shares here. Window. This one? I think it's this one. Yes, we're on the right one. Okay, so this is that repository. Let's see. Can I zoom this one in as easily as I can in the browser? Yes, I can. There we go. So this is that repository, and you can see all I'm doing is installing virtualization host. What if we add another? I don't know. What's your favorite package? Tmux. Let's add Tmux. I forget if I added that in the initial build or not. So now we're just going to add, after we do the group install, we're going to add Tmux, right? Now I'm just going to save this. And then I'm going to give it a quick commit message. We're going to stage that, commit it. We're going to sync the changes up. Now I'm just pushing into main. Obviously, that's probably not recommended if you're on a large team. Get my SSH password in there. I'm typing too fast and getting my password wrong. And what this is going to do, one more time. Hopefully that's the last one. Okay, what this is going to do, and now I got to switch back over to GitLab. This will automatically get my screen up here. If I go over to the jobs here, build jobs, it's going to automatically kick off a new job. See, I've already got a new containerized job running because all I did was push, and the way CI is configured on my GitLab instance is when there's a new push to main, rerun the build, right? So you saw earlier with Matt, when he did his changes, he had to kick off a job. I don't know if you can change that so it does it automatically, but in this case, it's just going to do it automatically, right? Now, I'm not going to sit here and make you watch the whole process here, but what this will do is it'll go through and execute all the steps of that CI file that I showed you earlier. Let's go back to jobs and show you the last one that I did. Now you can add unit tests in here too, which I haven't really tinkered with, but you could do something like start the container and test to make sure something has worked properly, right? Let me get back to the top here. But you can see here, this was the last job that ran. There's a lot of packages it installed because I installed that group, that virtualization host group. But you'll notice if I go all the way to the top, all those jobs that were in the upstream container, all the things that linked in that set up the environment and linked in the authentication. This is a lot longer than I thought it was going to be. Don't have to happen on this one because they were already in the upstream container. Yeah, so this is a lot to get through. We're on line of 1,000 and I'm not even close to the top. Anyway, I think you get the point.
Yeah. Yeah, the virtualization group is pretty big.
It's big. It's big. Okay. So that's essentially what I was going to show you. Oh, I guess there was one other thing. Let me show you one last thing here. I have to switch my screen share once again. So I mentioned that you can do unit tests. Now, I haven't done any tinkering with unit tests, but one of the ways that image mode I think is kind of cool is, we build that image. It's a bootable container image, right? Well, how can I test that image without deploying it to a machine? And it's actually really cool. You can just run it inside of Podman or Docker. So remember we said it's an OCI compliant container image. So I'm going to do a Podman run. We're going to run it interactively. We're going to tell it to remove it when it's done. That's what the -rm is for. And then we're just going to point it at my RHEL 9 image mode hypervisor image. Now, this will be the one I built before tmux because that job was still running. But if I run this, what it should do, I already have the image pulled down. I did it before the show because it's like 1.5 gigs or something. But I'm now running it within Podman. Now that looked a whole lot like a machine booting up. That's because it runs full systemd within this bootable container image because it's a bootable container. It's meant to be a full image. You'll see that some services failed. A lot of these are things that you might expect to fail because it doesn't have a full kernel and a full booted system to work with inside of the container. So those are things you won't be able to test inside of the container. But did my files get copied in? Is the web application tree intact inside of the container? Does the Apache service start up, right? Those are all things that I could easily test from within here. So
yeah, and we are working on tools too within Podman Desktop and also, I'm not sure the status of the actual Podman CLI, but being able to spin up a virtual machine really quickly without actually having to build the image and like launch it and build a QCOW and like import it, which is what I do on a regular basis. It takes a little while. We're looking at ways to be able to run it this way so you can do that quick test and then also like spin up a virtual machine really quickly with Podman machine.
Yeah.
So that way you can do more like, oh, but I really need like to test that this kernel patch applied or something along those lines, or a kernel argument. What's that?
Yeah.
So we're looking at ways to make sure that you can do those sorts of things locally, right? So you get that sort of full local development and testing environment without too much effort.
So the one thing I do want to learn kind of next is how to do unit tests against the bootc containers or unit tests against containers in general. Because like I said, I'm not a developer. I've got very little experience with all of this. And I would love to figure out for those handful of containers that I manage, right? Like when I do that build, I want to make sure the thing works so that when I try to deploy it to my things, I'm not deploying a broken container. So
yeah, you and me both.
Yeah, right. That's the next thing to figure out.
Yeah.
Okay, so that was essentially what I wanted to show. We're at 12:59. You still had something to talk about with tags. Do you want to cover that quick, or is that going to take too long?
We can do it quick. Cool. I think there's one other thing though that I want to show in order to talk about something that's in comments about Grub 2 and boot containers and these sorts of things. It's something that I harp on maybe a little too much. But if you want to flip back to my screen share, this is out of our official like technology deck. So you might see this if somebody comes to a road show.
Oh man, is this a slide, Matt?
It is a slide, but it's an important slide.
You broke the rules.
I know the rules, but this is like my pet peeve that we really don't explain well, and I want to make sure. Right. Okay. We talk about all this stuff being in containers and containerized. Containers are just the transport and build mechanism. What is happening on the system is not in any way, shape, or form anything you would normally suspect or expect with a container. What is inside the base image we publish is relatively in the terms of what people think about in containers, it's massive, right? These images are 1.5 gigs, right? It
Yeah.
has a kernel, it has systemd, it has grub, it has firmware, it has network manager, it has all sorts of things you never need to put in a container to run an application, because they're not containers in that sense, right? That's why I talk about them as bootc images and not container images, is because these are full RHEL hosts, right? So I just want to make sure that when we so the question in chat was about, do we just add grub to a container? It's like, no, this is a fully specialized minimal RHEL system.
It's a disk image.
Useful, but it's bootable right now. Like, you could just grab our base image and boot it. You can't do a lot because it's like
you would. I think you would make these more akin to an image that just came out of Image Builder, except it's
correct,
built to run in a different way, right?
Yes.
So Image Builder spits out a bootable virtual machine. It's a disk image that's a full operating system. That's essentially what you're dealing with here, except it's packaged up differently and it's made to be deployed differently.
Exactly. So yeah, if you think about our KVM images or something that you built out of Image Builder, right? Like, that's what we're talking about. We're not talking about UBI that like you throw grub into and expect to work. Like, it's a lot more complicated than that.
Right.
Cool. Yeah. So this was our published image, right? So it published an hour ago. So one of the things right on tags. So these are tags that we added during the build. So GitHub adds these, and you can see, we still have some other things that Quay is warning us about on our security stance. But the thing to know about images that I want to get across, when we were talking about it earlier with like, do you use specific tags or other tags? Tags are just metadata. Like, they don't come from anywhere other than the people who add them during build systems. So you'll see this little line over here. This is this SHA manifest is what, like, if you really want to be like very specific, the application folks tell you to use the SHA, because you can tack whatever label you want on things. So it's all about what you want to do and how you manage your tags, right? So one of the things you could do, and this is in my mind, right, is you could use this to your advantage to say, we have dev things, we have test things, and we have prod things.
Right.
But the way that you control visibility across all of your environments is simply take a tag and say, we're going to add dev onto this because this is our last build. It's not ready for prod. We could tag it to dev, and then only the development machines that are tracking CI demo dev would see it. If they're tracking test or prod,
right,
they would never even know that there was something available to be updated to, right? So not only does that give you like a sort of like lifecycle environments for packages, it also means you're not rebuilding things lifecycle environment to lifecycle environment using the same starting point. You are literally using this image that you validated through your testing and saying, this particular image is known good.
Right.
It should now move along. Right. So
now
literally are moving the same binary artifacts.
Think about that in a package mode world, right? You've got a server, it's out there, it's in the wild, it's doing its thing, and it works great, right? And now it's patch day. Now you go in and you install patches, and they install the way they install, and that's pretty predictable. But what has happened to that machine since the day it was built to the day that you're installing those packages, right? There's so many things that I've seen go wrong in that time frame. What if you hadn't been updating this machine? I know that's bad practice, but what if it's been a year since you've applied updates to it, and in the meantime, like, certificates changed or something? Now all of a sudden DNF is like, I can't talk to the repo because it doesn't have the certificates that it needs. Now obviously there's ways to fix that, but at 2 a.m. when you're updating that production system, you don't want to have to think about that. You want to get the job done, make sure it works, and make sure that it's ready for production so you can go back to bed, right? With this, what you're doing, also, here's another great use case, and this is like tinfoil hat, right? Say there is an undetected compromise on that machine. And this is one of the beauties of containers too, right? There's an undetected compromise on that machine. right? When you do a bootc upgrade, it's eradicating the entire immutable tree, right? I shouldn't say eradicating, it's replacing, right? And there's a good chance that that undetected vulnerability or undetected compromise just got overwritten. And you reboot the machine and now it's gone, right? You may have never even known it was compromised. If you did know it was compromised, re-image it and up it comes without the compromise, right? Now that's not foolproof, right? Don't get me wrong. I'm not saying this is the solution to all of our compromise woes, but it's exactly the deal with a container, right? Container, someone breaks out of the service running in your container and they do nasty things to your container. You just nuke it and build a new one, right? Well, now you can do it with actual RHEL hosts, which I think is pretty cool. Sorry, I went on a tangent.
Yeah, no, it's perfectly fine. But yeah, and this also gets back to that conversation about do you DNF update in your container build or not? Like, well, this is part of it, right? Like,
right.
How much control and how much when you know, like, now the good thing is like if you're using I'm going to call it RHEL because like in personal practice on my laptop, I use just the containerized registry that has no interface. But things like Quay will have security scanners. If you've got other security scanners for container tools, it will actually tell you, like we mentioned, right, containers are just tarballs with fancy metadata. Well, these manifests, right, you can actually see all of the stuff that's in there. So there's other ways to track like where packages are and what's been going on in the image build.
Right.
So it's not that it's completely invisible. It's just a matter of where you need to see it and how you want to dig for it.
Right.
So yeah, and these are all things that, either we have wired up other places, so we're not losing, right? We're not going to lose security scanning because we move to containers, because we can now do it in multiple places. We can get it at image level and then at host level, because you can still run your Nessus scan or CrowdStrike or whatever else on the actual host. Right. So we're now getting back to your suspenders. Like we got belts, we got suspenders, and we have like rivets that we're now putting on things to make sure stuff doesn't fall down.
There's a question in chat. Do you still need the share up? I don't know if you do.
No, you can pull that down.
There's a question in chat. Is there a way to factory reset both Etsy and var? And this is probably a follow-on to the thing I was talking about with compromise, right? Because if they wrote nasty stuff to Etsy or var, then it's going to persist.
Yeah, not at the moment. We are still exploring. It was something that we've talked about for a while. It was one of the first things that came to my mind too. The question is always just how reset is reset, right? If you go back to Nate, your point about your first boot script and getting all your users that way, if we factory reset it, would that actually, like, how far did we go? Like, you're no longer able to log in.
Yeah.
Okay. Hopefully that your first boot script also comes back, so that still works. But like there's some design considerations that they have going around on just how reset is reset before it becomes
just a rebuild.
We reset it to the point that it is no longer able to even be logged into.
Yeah, I mean, so that's actually a valid point though, right? How much of the system is gone before you may as well just rebuild it anyway, right? And it would be relatively trivial to rebuild one of these machines, especially if it's virtual. Just spin up a new disk, a new machine, image this down to it, the same image. Now you've got the thing up and running in the same base configuration already. All you need to do is get that persistent data moved over to it, like you would with a container.
Yeah. I mean, we already get, like, this is a brand new technology for a lot of folks. So like, this isn't a knock on anyone. It happens to me all the time because I forget, like, the mechanisms for updates and things that maintain Etsy, like that goes out the window when you roll back, right? It literally says, oh, I'm going back to this other deployment that is currently on disk. So whatever state was there, right? And this is probably a little too deep, but this is Colin's words. Like, think of libOS tree, right, as a fancy hard link maintainer. Like, all these things are just hard linked. So when you made changes to Etsy, it hard linked it into the deployment Etsy file. So changes you made to Etsy between the rollback will go away, right? So people get tripped up by that. If we then go and say, well, now we're going to factory reset it. Well, okay, how far was factory reset?
So what you're saying is if I bootc update and then reboot and it's up and running, and then I make changes to Etsy,
Mhm.
and then I realize something is wrong, and I do a rollback. The changes that I made to Etsy while on the new image would be lost,
Correct.
right? Okay. I just
Correct.
want to clarify that to make sure people were understanding that the flow
Yes.
there.
Yes. So it can trip you up if if you do make a change and then you roll back because something else went wrong that wasn't an Etsy change, and now your Etsy change is missing. Like
Right.
it's something important to know because we talk about the three-way merge a lot, but that's only on sort of forward moving things for updates and changing to new images. Rollback is literally you've got the two and we're just gonna boot the old
Switch
one.
it back. Which makes sense, I would think, right? Because there's a good chance that if there's something's wrong, it could be in Etsy,
Right.
right? So we should like if you're going to roll back, you should roll back Etsy too, because
Yeah.
that's where all your configuration lives.
Exactly.
So yeah. All right. So this has been a fun conversation. Let's see. Would RHEL be getting to a point in time? Sorry, would RHEL be getting point in time snapshot of the entire file system to make the reset easier? I'm not sure if I understand the question.
So I think the question's about what we were talking about and how much of Etsy and VAR do we change.
Okay.
And the discussion so far hasn't gone. So the discussion so far has not gone into things like using file system level snapshots. One,
Right.
because there's a lot of overlay weird things going on above the file system. So like doing it at the XFS layer, like XFS isn't going to know what's going on at the ComposeFS stuff. So
Mhm.
it might not work the way you might expect. But the other thing is we do have basically full copies of the original VAR and Etsy in locations on disk that are internal implementation locations. So we can just it's kind of like the rollback, right? Like we can blow away Etsy and VAR easily to the state that exists in the build in the image originally.
Right.
So it's not a matter of how far back can we go, because we can go back to zero.
Right.
It's any intermediary like, okay, well, we also just blew away your host name and we disconnected you from insights. Was that really what you wanted us to do?
Yeah, right. Because you lost the system ID and whatever
Right.
subscription data and
Yep.
the insights
The machine ID
connection
has changed.
and
Yeah. So
like, oh, the MAC address that we had inside of UDEV is lost. Right.
exactly.
Now we've got duplicated network interfaces.
Yeah. So like right now we could do the emergency stop full. This is a new install style reset. But we may lose the ability to actually do things like create users if that was done, like say via the Kickstart.
All right. So there's one more question, and I think we're going to have to call it because we're already almost at 1:15. Yeah. So what do you think about
stuff, so it's my
what do you think about different styles of managing complex bootc container files? Currently migrating a system or a set of bash scripts with Ansible within the image build. Oh, to Ansible within the image build. Okay. So I guess I didn't even really think about Ansible within the image build. That's interesting.
Yeah, so we've been working with like the system roles folks and some other folks to actually do and think about how do you apply Ansible at build time, right? So,
right,
there's certain things that obviously like this really kind of brings back stuff that we've talked about, but like sort of ignored for a long time in operations, which is like real separation of build time stuff and runtime stuff. Like you can't configure the network until you actually have one, right? So that you have to do later. So that should be Ansible at runtime. But setting up NTP servers, like they don't actually have to exist. Like do that at build time. So generally, I think there's a lot of interesting things that we can do with complex container files. I think having the ability to maybe do some of this stuff templated. And somebody earlier mentioned things about environment variables available during Podman build, which I have used to like pass secrets into. So we're not leaking passwords and things like that.
Yep. So GitLab is leveraging that pretty heavily in my build because there's secrets that are stored within GitLab There's also Podman secrets that I'm passing from the build environment into the container build. So yeah.
Yeah. And I tried to figure out how to do it with things like, pass an argument to build to get the right repo, right? To say I want RHEL 10 versus RHEL 9, but there's some oddities there about how we name stuff. So I think like there's a wild unexplored space. And we've been in tech preview for about a year, GA for a few months, or maybe a month. So that is all in the wild west of, yes, you should try it. And like, there's probably a lot of things that we can take advantage of.
Yeah. I mean, this, I'm going to tell you the concept of image mode. And I mean, I think you were there a year ago when we were at Summit in 2024, when we first debuted image mode. Most of the questions I got in the booth were like, what now? Why would I do that? This is ridiculous. Why on earth would you want this fat, heavy container written to a disk? But then this year at Summit, when people had that year to stew on it, and now the messaging around image mode is just so much more clear. It's more like, oh, I could do that with this. I could do this other thing with that. And I think we're still just at the beginning of that path. I think there's going to be so many cool things that could come out of just image mode, and how to get automation done, and how to run things in container files like we were just talking about. I'm pretty excited about it. I love this feature of RHEL 10. It's one of the things I get most excited about when I talk about the new release.
Yeah, it is. For me, it's unlocked a lot of things that I set down, like your whole idea of like being able to do testing, right? Automated build and test, and know that at the end, like, you have something that you can just deploy to production and it's good to go. Like, we still have manual checklists and all sorts of other things we have to do by hand because we never were really able to solve that because we needed to instantiate a thing, right? Like, we had to have something running. And it got difficult.
Yeah, so I think this solves a lot of the promises that were made a decade and a half ago when we started talking about cloud. A lot of those ideas that people were having, I think some of them just were never really truly realized. They were all, there were ways to get them done, but none of them were clean. And this is a huge step, I think. Huge step. All right, so this has been a fun episode. I don't know that we're going to go deeper in the near future on image mode. It always feels like the deeper we get on a topic, the less interested people get on it. But as Red Hatters, we love to go deep on technology. So if folks are interested in more image mode, we have a bunch of content already out there. We've got a bunch of labs that you can get your hands on if you go to lab.redhat.com. We've got a bunch of blogs. I mean, there's a lot of Red Hatters talking about image mode right now. So you have a ton that you can consume. And feel free to comment if you've got questions that are specific to image mode. We can either get you answers, or if there's a recurring theme there, maybe we can have another episode. Go ahead.
We've got all those templates that we'll make sure we get in the show notes into the description, right? So like you can grab the GitHub template and just fire it up and start this on your own. Just same with the CI/CD ones that we've got for other environments too. So like we're trying to get as many resources out there and get people asking questions and hammering on it.
Yeah. Ask the hard questions too, because we want to be able to come up with answers and solutions to all of these things, because it is a different way of thinking about how to deploy and use RHEL. Go get a Fedora. Universal Blue. That's the spin I'm thinking of, or Bazite or something. That's based on bootc now. So you can get your hands on that and use it as a desktop environment. If you want to learn something, make your make your home computer depend on it.
Where the main product manager for image mode has gone all in, and literally everything he is running right now, from his home lab on Fedora to his RHEL desktop, are all image mode builds he runs through a local Git server, which is wild.
All right, folks. Well, thanks for tuning in. If you liked the episode, make sure to hit the like button. We gave you a bunch of other resources, so I'm not going to go that deep on those, except last week's episode. We also talked about some more basics for image mode. So if you need to get back to those basics, if you didn't see that one already, go back and watch last week's Into the Terminal. And I think that's it. You got any last words there, Matt?
No, no. Thanks for having me. I can sit here and talk about this stuff for hours and tangent all day long. So I'm glad we kept
This
it
may
to
be the
just
longest
over an hour.
episode. This may be the longest episode we've had of Into the Terminal. So I
Sorry.
believe it. All right, folks. Have a great one. We'll catch you next time.
Cheers.